Imagine looking at two frozen worlds billions of kilometers away and discovering something that should not be there. That is exactly what happened when scientists pointed the James Webb Space Telescope toward Pluto and Titan. Instead of finding only the familiar gases they expected, they detected evidence of a mysterious substance unlike anything previously identified in these distant atmospheres. It was not another planet. It was not a new moon. It was chemistry that nobody had seen before. And it could completely change how scientists understand the outer solar system. To understand why this discovery matters, we first need to travel to two of the strangest places orbiting our sun. The first is Pluto. For decades, Pluto was known as the ninth planet. Today it is officially classified as a dwarf planet, but that label does not make it any less fascinating. Pluto is covered with vast plains of frozen nitrogen, towering mountains made of water ice, and enormous glaciers that slowly creep across its surface. Temperatures there fall to around -230 degrees Celsius. Sunlight is so weak that noon on Pluto feels dimmer than sunset on Earth. Yet despite these brutal conditions, Pluto has an atmosphere. It is incredibly thin, mostly nitrogen, a little methane, a little carbon monoxide. As Pluto moves farther from the sun, part of this atmosphere freezes and falls back onto the surface like snow. The second world is Titan. Titan is Saturn's largest moon and one of the most Earth-like places in the solar system. Not because it is warm, it is even colder than Antarctica by more than 100 degrees. Instead, Titan has weather, it has clouds, it has rivers, it has lakes, but none of them contain water. They are filled with liquid methane and liquid ethane. Rain falls from orange skies. Rivers carve valleys through frozen landscapes. Entire seas stretch across the poles. It is the only moon known to have a complete weather cycle. Even though Pluto and Titan belong to different parts of the solar system, scientists have long noticed something unusual. Both worlds are wrapped in a thick orange haze. From a distance, that haze hides the surface beneath. For years, researchers believed they understood what created it. Sunlight breaks apart methane molecules high in the atmosphere. The fragments collide with nitrogen. Thousands of chemical reactions follow. Tiny particles begin sticking together. Eventually, they become aerosols, microscopic solid particles floating through the atmosphere. That explanation seemed to fit the observations until James Webb looked closer. Unlike ordinary telescopes, James Webb sees the universe primarily in infrared light. Everything gives off infrared radiation. Different molecules absorb different wavelengths. That means every gas leaves behind a unique fingerprint. Scientists can read those fingerprints almost like scanning a barcode. When Webb observed Pluto and Titan, researchers expected to see familiar chemical signatures. Instead, something unexpected appeared. The data contained spectral features that did not match known atmospheric models. In simple terms, there was evidence for material that scientists had not predicted. Nobody immediately announced the discovery of a brand new molecule. Science does not work that way. Instead, researchers began asking careful questions. What exactly is producing these signals? Could it be an unknown combination of organic particles? Could existing models be incomplete? Or are entirely new chemical reactions taking place in these frozen skies? Those questions remain unanswered. That uncertainty is exactly why the discovery is exciting. Finding something unexpected is often where the biggest breakthroughs begin. History is full of discoveries that started with one strange observation. Radio waves, X-rays, dark energy. None of them were found because scientists were searching for them. They appeared because nature refused to behave as expected. Something similar may be happening here. One leading idea involves photochemistry. Although sunlight reaching Pluto and Titan is incredibly weak compared with Earth, ultraviolet radiation still has enough energy to break apart methane molecules. Once methane splits, carbon and hydrogen atoms begin reacting with surrounding nitrogen. The atmosphere becomes an enormous natural chemistry laboratory. Reaction after reaction builds larger and larger molecules. Some eventually become sticky enough to clump together. Scientists suspect this chain of reactions may produce substances never before observed in laboratory experiments. If that is true, Pluto and Titan are manufacturing entirely new types of atmospheric particles. These particles may explain the famous orange haze surrounding both worlds. That haze is more important than it appears. Tiny particles floating high above the surface scatter sunlight. They determine the color of the sky. They influence how much heat escapes into space. They even affect weather patterns. On Titan, the haze helps shape a climate that supports methane rain, rivers, and lakes. On Pluto, it changes how energy moves between the surface and the atmosphere. Understanding the haze means understanding how these worlds function. James Webb is giving scientists their best view yet. One reason this telescope is so powerful is its enormous mirror. More than 6 meters across, it collects faint infrared light that would be invisible to previous space telescopes. Combined with incredibly sensitive instruments, Webb can detect tiny chemical differences across billions of kilometers. That ability is transforming planetary science. Instead of simply photographing distant worlds, Webb can investigate what their atmospheres are made of. It is almost like taking a laboratory instrument into space. This discovery also raises fascinating questions about life. To be clear, scientists are not saying they found evidence of living organisms. There is absolutely no proof of life in these observations, but many complex organic molecules can form without biology. On early Earth, similar chemistry may have helped create ingredients that eventually led to life. Titan has fascinated researchers for decades precisely because it contains rich organic chemistry. Understanding these reactions helps scientists understand what kinds of chemistry are possible throughout the universe. The more chemistry nature can invent without life, the better we understand the path from simple molecules to complex ones. There is another lesson hidden inside this story. We often imagine that exploration means visiting new places. Sometimes it means looking at familiar places with better tools. Pluto has been studied for decades. Titan has been explored by spacecraft including Cassini and the Huygens lander. Yet one more powerful telescope revealed something nobody expected. Better instruments often change science more than better ideas. Every generation builds sharper eyes. And every generation discovers that nature is more complicated than anyone imagined. Researchers are now working to identify exactly what this mysterious material is. That process could take years. Laboratory experiments must recreate conditions found in Pluto's and Titan's atmospheres. Computer simulations must test thousands of possible reactions. Future Webb observations will collect additional spectra. Eventually, the puzzle pieces may fit together, or they may reveal even stranger questions. That is how science progresses. Every answer opens another door. Every discovery reveals another mystery. Perhaps the most remarkable part of this story is not the substance itself. It is the reminder that our solar system still contains genuine surprises. These are not distant galaxies billions of light years away. These are neighbors, worlds we thought we understood. Yet floating high above two frozen landscapes is chemistry that refuses to fit our expectations. James Webb was designed to study the earliest galaxies in the universe. Yet it continues making extraordinary discoveries much closer to home. Sometimes the greatest mysteries are not hiding at the edge of the cosmos. Sometimes they are waiting inside a faint orange cloud drifting silently above an icy world. The universe still has secrets, and with every observation, James Webb is teaching us that even familiar worlds can become completely new again.